Hello ma'am, there is the confusion in between different types of pressures in the condenser. What is the difference in between ideal pressure and actual pressure in the condenser? Also tell us how to calculate the saturation pressure in the condenser. To understand the ideal vacuum as well as actual vacuum, let us first understand different types of pressures with the help of diagram. So first we will say lowest pressure or highest vacuum in condenser is the saturation pressure of steam corresponding to steam temperature entering in the condenser. Now if we observe this diagram here, entrance of condenser is shown here, that is the steam is entering into condenser from this point. So at this point we can say that corresponding to temperature of steam at this point, so I will say here Ti, that is the at the entrance, so I will say at the inlet of condenser Ti, at this temperature what is the corresponding pressure, that is the saturation pressure. So its notation is PS. So we can say that pressure at this point or pressure at the entrance of the condenser corresponding to this temperature is known as PS, and this pressure is known as saturation pressure. We will also say lowest pressure or we will say highest vacuum. So this term that is important. Now we will move for the next. So actual pressure. So what is the definition for actual pressure? That is the ideal pressure plus partial pressure of air in condenser. So whenever there is air in condenser, then it is the addition of ideal pressure plus partial pressure of air in condenser. Now total pressure. So how we can define the total pressure? So total pressure of air and steam, that is the addition of pressure of steam, that is PS, plus pressure of air. So we can say that here is the suction at the air pump, or here is the air leakage is taking place. So I have shown here with A. So air leakage is taking place. So suppose here for this air leakage we will say temperature at this point is TA, that is the temperature for the air leakage. Then the pressure corresponding to this temperature is known as the pressure of air, that is PA. So I will say that at this point there is the pressure PA, and because when air leakage is there, so remember whenever air leakage is there, then there is the pressure corresponding to air, that is PA is present. Now we will move for the next. So how we can define the total pressure? So total pressure is the addition of PS plus PA. Then next point is the barometric pressure. So barometric pressure, that is PB. So it is also known as atmospheric pressure. So I will show outside the diagram, that is the atmospheric pressure, that is nothing but PB. So this is the barometric pressure or atmospheric pressure. Now we will understand what is the ideal vacuum as well as actual vacuum in the condenser. So when there is no any air leakage, so there is no any air leakage, only at the entrance there is the pressure of steam PS and barometric pressure, that is atmospheric pressure PB is there, then that vacuum is known as ideal vacuum. And how to calculate this ideal vacuum? That is PB minus PS. And what is the meaning of actual vacuum? So actual vacuum, that is with air leakage. So when air leakage is there, that means here PA is present, then how to calculate the actual vacuum? That is, we have to take the difference of this barometric pressure plus total pressure. So total pressure means what? PS plus PA. So PB minus in the bracket PS plus PA. So this is the formula for the ideal vacuum and actual vacuum. So when no air leakage is there, then only PB and PS is present. Now we will move for the vacuum efficiency. So vacuum efficiency is the ratio of actual vacuum by ideal vacuum. So we will put here the formula, that is PB minus in the bracket PS plus PA divided by PB minus PS. So With this formula we can calculate the vacuum efficiency. Now to find out the different values related to these pressures, we will first take one example. I will read that problem. The following data collected from steam turbine of 30 megawatt capacity thermal power plant. Steam condensed 50,000 kg per hour. Temperature of steam in condenser 40 degrees Celsius. Dryness of steam entering into condenser 0.85. Air leakage in the condenser 150 kg per hour. Temperature of condensate 35 degrees Celsius. Temperature at suction of air pump 32 degrees Celsius. Barometer reads 76 cm of Hg, which is equal to 1.013 bar. Find vacuum gauge reading in the condenser. Capacity of dry air pump. Loss of steam in kilogram per hour going with air. Quantity of cooling water passed through the condenser per hour if the rise in cooling water temperature is limited to 10 degrees Celsius. So this was the given question. Let us first understand given data with the help of diagram. Now here steam turbine capacity 30 megawatt is given. So this is the turbine capacity. So before this condenser, here is turbine, and this turbine capacity is 30 megawatt. So we will write here. Then steam condensed is 50,000 kg per hour. So here this is the quantity of steam condensed, that is the amount of steam condensed. So at the outlet we have to write here 50,000 kg per hour. Then temperature of steam in condenser. So this is the temperature of steam at the entrance of the condenser is given, and it is 40 degrees Celsius. So we will write here the temperature is 40 degrees Celsius. Then the dryness fraction of this steam is also given, that is 0.85. So at the entrance it is given the dryness fraction, that is here the mixture of water vapor plus water is given, that is because this is the dryness fraction, that is 0.85. The air leakage is also given, that means in this case there is the air leakage. So air leakage is 150 kg per hour. So here is the air leakage, so I will show here 150 kg per hour. Then temperature of condensate. So here the temperature of condensate is given, that is at the outlet of condenser this temperature is 35 degrees Celsius. Then the temperature at suction of air pump. So here at the suction of air pump, so here is the air pump and this temperature is given, that is 32 degrees Celsius. And barometric pressure is also given. So barometric pressure is known as the atmospheric pressure. So here this PB is given, that is 76 millimeter of Hg. So here this is in case of millimeter of Hg, and which is equal to 1.013 bar. So 1.013 bar. So this barometric pressure is also given. So this is the given data. Now we will move for the calculation part. We will move for the first question. We will calculate vacuum in the condenser. So how to calculate the vacuum in the condenser? Now here is the case of air leakage. So we have to first find out the total pressure, that is the pressure of steam plus pressure of air, that is PS plus PA. And vacuum in the condenser, that is barometric pressure PB minus total pressure. So let us first find out what is the pressure of steam. So here steam is there, so we will refer here the steam table. So temperature is given 40 degrees Celsius. So at 40 degrees Celsius we have to refer here the temperature table. So if we observe saturated water and steam, temperature table is there, and in the first column temperature is given. So for 40 degrees Celsius we have to find out what is the pressure. So here the pressure is given in the second column. So this pressure is 0.0752 bar. Now we will calculate what is the pressure of air. So for air we have to use the different formula because the fluid is air. So how to find out this? So formula to find out the pressure of air, that is we know that PV is equal to mRT. So for these gases or air, this formula is used. So here air is there, so we will say that PAV is equal to mRT. Now m is the mass of air, so it is given 150 kg per hour. R is the gas constant, T is the temperature. So how to find out the volume? So if we observe here, whenever the steam is entering into this condenser, then the dryness fraction is 0.85. And here is the mixture of, at this entrance, here is the mixture of steam as well as air is there. So volume occupied by the steam, that is equal to the volume occupied by the air. So we have to take the same volume, that is for steam as well as air. So it is easy for us to calculate the volume occupied by the steam. So how to calculate the volume of steam? So this is equal to, now rate of flow of steam is given 50,000 kg per hour. So we will use this rate multiplied by the dryness fraction 0.85, and we will multiply here the specific volume. So again, for specific volume at 40 degrees Celsius, we will refer here the steam table. So at 40 degrees Celsius, we will refer the value of the specific volume, that is 19.5. So here is the 19.5, that is Vg, because we have to find out what is the specific volume of the air, that is it is in the gaseous state. So steam is in the gaseous state, so we have to refer here Vg. So what is this Vg? That is 19.5. X is 0.85 and 50,000 is the rate of flow of steam. So in this way we can calculate this total volume, and this volume is also occupied by the air. So this is the formula for the volume of steam, but that is equal to volume of air. So when we calculate this, we will get 828750 meter cube. So this is the same volume that we have to refer here. So now we will calculate the pressure, that is mRT divided by V. So standard unit is Newton meter square, but we have to take this value in bar because PB is also given in bar. So we have to divide here with 10 raised to 5. Now we will take M, that is 150, so it is given. Then R 287, so this is the ideal gas constant. T, so temperature we have to take in Kelvin. So here 40 plus 273, that we have to take, divided by 828750 into 10 raised to 5. So answer is 0.000163 bar. Now PT is equal to PS plus PA. So this is the PA and PT is the total pressure and PS is here. So these two values are important. So if we add, we will get PT, and vacuum in the condenser, that is this barometric pressure minus this total pressure. So we have to calculate this, and this is the answer of the first question. Now we will calculate the second question, that is air pump capacity. So for that we have to find out what is the volume at this air pump. So how to find out the volume at air pump? So this is the air. So we have to use the formula regarding air, that is PV is equal to mRT. So what is this P? So P is the pressure of air. So pressure of steam at the air pump, that we have to find out. And temperature we have to take here 32 degrees Celsius. Mass, M is mass flow rate 150, that we have to take. So let us first understand how to find out the pressure of steam at air pump. So whenever air leakage is there through this air pump, then there is steam is also there. So pressure of steam at the air pump suction at 32 degrees Celsius. So again we have to refer here the steam table. So temperature is given, that is 32 degrees Celsius. So we have to refer here the temperature table. So in the first column there is 32 degrees Celsius, and the pressure we have to refer here PS1 is equal to 0.0485 bar. So in the second column pressure is given, so we will write this pressure. So this pressure is given in bar. So this PS1, so suffix 1 is used for this at the suction of this air pump. So pressure of steam is there. Now we know what is the total pressure. So PT that we have already calculated in the first question. Now pressure at air pump. So pressure of air at the air pump, that is PA, that we have to find out. So we know that the total pressure is nothing but the pressure of steam plus pressure of air. So PS1 is there. Now we have to find out PA1. So remember, suffix 1 is used for the suction at the air pump. So PS1 is there. PT we have already calculated, that is the total pressure. Then we will calculate this PA1. So PA1 is equal to 0.02686 bar. So now this PA1 that we get, now we will use the formula, that is PA1 V1 is equal to MRT. So PA1 we will use this pressure, then V1 that we have to find out. So this V1 that is nothing but the air pump capacity, which is equal to M. So M is 150, R that is the ideal gas constant 287, and T temperature is 32 degrees Celsius, but we have to take in Kelvin, so 32 plus 273. Now if we observe, this pressure is given in bar. So we have to convert it into standard unit, that is Newton meter square. So we have to multiply here with 10 raised to 5. So when we solve this, then we will get the answer, and V1 volume is equal to 4848.4 meter cube per hour. So this is the air pump capacity. Now we will move for the third question, that is the loss of steam with air. So if we observe this diagram, at the suction of this air pump, when there is the loss of air or air leakage is there, then at the same time steam is also getting leaked. So how to calculate what is the loss of steam? So if we observe, we have calculated what is the volume V1, that is the V1 volume is for the air leakage or capacity of the air. To calculate the capacity of air pump, we have calculated this V1. Now we have to calculate what is the specific volume of steam at the temperature of this 32 degrees Celsius. So we have to refer temperature table. So here in the first column, temperature is given 32 degrees Celsius, and we will find out what is the volume of steam, that is Vg, because steam is in the form of gaseous state. So we will take the value of Vg, that is 21.6 meter cube per kilogram. So here this is the Vs1. So how to calculate the loss of steam in kilogram per hour? So out of the total volume V1, we have to divide by Vs1, that is the specific volume of steam. Then we will get 163.8 kilogram per hour. So this is the loss of steam in kilogram per hour. Now we will move for the next question. We will calculate what is the mass of water or mass flow rate of water in the condenser. So if we observe, here is the inlet of water and here is the outlet of water, and rise in temperature is given 10 degrees Celsius, that is the temperature difference TWO minus TWI, that is equal to 10 degrees Celsius, that is given in the question. So we know that when the heat transfer is taking place in the condenser, then heat lost by steam is equal to heat gained by water. So here dryness fraction X is given. So we can say the formula, that is we will take the enthalpy difference of the steam, heat lost by steam. So here the enthalpy is H1, and here enthalpy, because at the outlet there is the saturated water is there. So enthalpy is HF2. So here is the 0.1, here is the 0.2. So H1 and HF2, we have to take the difference. So I will write here. So at the entrance there is the H1, enthalpy H1, and here is HF2, because at this point the mixture of steam and water is getting converted into saturated water, which is equal to, now heat gained by water, that is mCp delta T, that is MW CPW, specific heat and temperature difference. Now Ms, so what is this Ms? So we know Ms, then H1. So we have to calculate this enthalpy at point 1. So how to calculate? Because here the dryness fraction X is given, we will use the formula HF1 plus X1 HFG1. Now what is the temperature? So it is 40 degrees Celsius. So again we will refer here the temperature table. So at 40 degrees Celsius, what is the value of HF? That is 168. So we have to take 168, X1 is given and HFG. So HFG is also there, that is 2414. So we have to take this 168 plus X1, that is 0.85 into 2414, that is 2219.7. So this is the value of H1. And what is the value of HF2? So this is the saturated water at 35 degrees Celsius. So 35 degrees Celsius we will find out the value of HF, that is 147. So we will take here the 147. So if we put the value of H1, HF2, then MS is mass flow rate of steam 50,000 kilogram per hour. Then CPW, it is 4.2 kilojoule per kilogram degree Celsius, and temperature difference is given 10 degrees Celsius. So when we put all the values, then we will calculate MW, that is 587 into 10 raised to 3 kilogram per hour. So this is the answer.